For this video, we are going to learn how to find the arc length, or the length of an arc with both degrees and radians. So the first one I'm going to do, we're going to look at degrees. Make sure that you are taking notes on this so that you have them to refer back to when you're looking at IXL. Alright, so remember the arc length is on the outside. If you think about your circle as a piece of pizza, it's like the crust. So this is the arc length. And maybe they gave us that this was 120 degrees. And maybe they told us that the radius was 4 inches. And wanted us to find the arc length, which is right here. Well, if you think about the entire circle, you're thinking about circumference. And so S is usually the variable we use to denote arc length. S is going to be 2 pi r, but 2 pi r represents the entire circle. We don't want the entire circle, we just want a fraction of it. So I'm going to do my fraction. Well, in the bottom, I'm going to put 360. The reason I put 360 is because the entire circle has 360 degrees. Every time I do a problem like this, I'm going to have theta be in the numerator. Theta is the central angle, so this piece. So all we have to do is plug things into our formula in order to figure it out. So S here is going to be 2 pi times 4 times, in this case it's 120 over 360. And a lot of times our questions will ask it, the question will say leave it in exact terms or something like that. And that just means that it wants it in terms of pi. So it doesn't want you to simplify in that way. So this is going to be, we're going to multiply everything except for the pi. So 2 times 4 is 8. And then if I simplify this fraction, it's going to be 1/6. Oops, that's not right. It's going to be 1/3, and then pi. So the way that we like to say that is 8/3 pi. That is the arc length for this particular arc right here. The other option is for us to find the arc length if they give us the central angle in radians. So in the same way, this one is going to be radians. Radians is just the angle measure that they gave us. In the previous problem, they gave us degrees. Now we're looking at radians. All right, so again, maybe let's think of a different piece. Maybe this time they gave us that the central angle, remember this is the central angle, is 4 or pi over 4. And then maybe this time they told us that the diameter is 10. Let's think about that for a second. All right, so if this is our problem, we're going to start off using the same idea. S equals, if we want the arc length, that's on the outside, that's like our pizza crust. And so in order to find that, we start off with 2 pi r, which is their circumference, and then times theta over 2 pi. Now the reason I use 2 pi is because we're dealing with radians. And in radians, all the way around the circle is 2 pi. But if you look at this, we're able to simplify by crossing some things out, right? The 2's cancel and the pi's cancel. So S is equal to r theta, which you could also use, but only if you're given radians. So we're just going to plug in. This case, because they gave me the entire diameter, I'm going to have to say that r is equal to half of the diameter, which is 5. And then theta is my central angle, which is right here. So that's pi over 4. And so I could simplify that by saying 5 pi over 4 is the length of this arc. Now we're going to look at the area of a sector. So we're still thinking about just a section of our, do something maybe like this. Still thinking about a section of our circle, but this time instead of thinking about the pizza crust, we're thinking about this like whole thing, the area. All right. And maybe in this case they gave us that the theta, this one's going to be degrees. Theta is going to equal, we could say 60 degrees. And then our radius, let's say, is 7. Okay, so the formula for this one would be like thinking about the area of the entire circle, which is pi r squared, and then times theta over 360. Remember, it's 360 if it's in degrees. So it's really similar, but this time we have to use the formula for the area of the circle as opposed to the formula for the circumference, because we don't just care about the edge, we want the entire section. So my r is going to be 7, and theta here is going to be 60. So 7 squared gives us 49. And then 60 over 160 reduces to 1/6. You can use your calculator and then do the math, enter, if you want to convert that, or if you're struggling converting that. And then if we multiply everything across, what ends up in the numerator would be 49. 6 is in the denominator, and then got to keep our pi. So this entire section is 49 over 6 pi. And we could convert that into a decimal if we wanted to. When you do your IXL, though, I think it asks for exact measures, and so you're going to have to keep it in terms of pi. And the last problem is how to find the area of the sector if you were given radians. So for this problem, let's have pi over 2. You should be thinking about how pi over 2 is equal to 90 degrees. But anyway, pi over 2 is going to be my central angle. And then I'm going to have maybe a radius of 11. It's a good number. All right, so in order to determine the area of the sector using radians, we're going to do exactly what we did the last time. Start off with pi r squared. But this time, when we're getting the fraction that we wanted, we're going to have 2 pi in the denominator and theta in the numerator. Before I plug in, let's simplify this. Our pi's are going to cancel here, right? Because we have a pi up here and then a pi here. So it's going to be r squared over, or times theta over 2. So then for r, we're going to plug in 11. 11 squared. Theta here is pi over 2, then divided by 2 again. So this is going to be 11 squared, which is 121, times, this is going to end up being pi over 4. And so our final answer would be 121 pi over 4. And remember, that's talking about the area, which is the inside piece. Make sure you refer back to these formulas when you are working on your IXL. The ones on your IXL are mostly in degrees, so you can keep that in mind, that the formulas for radians aren't as important. Make sure that you take your time, that you have a separate sheet of paper showing all of your work.